Hey Leila, this is Dylan. I'm going to be teaching you how to decompose fractions today. So we have a problem here, which is 31x squared minus 32x minus 14 over 15x cubed minus 11x squared minus 14x. So our first step is going to be factoring out this denominator. So we have an x in all of these terms, so we can take out an x. And then this is a quadratic equation that can also be factored out into this here. Now, to determine if we have a non-repeating linear, repeating linear, a non-repeating quadratic, or repeating quadratic, we're going to look for any squares in the denominator. So if you have a square root here, let's say, or on the outside of any set of parentheses, you are going to have a repeating fraction. Now, if you have nothing, it's not repeating, and it's also linear. If you have a square root here of one of the x's, you have a quadratic equation. And if you have both, then you have a repeating quadratic equation. Now, this, despite being a quadratic equation up here, is not a quadratic equation down here, as it is factorable into linear terms. So our next step is going to be multiplying out all of these terms in the denominator to, sorry, it's not going to be that. We're going to take our, each of these terms in the denominator, we're going to set a variable that does not repeat, so a, b, c, d, e, f, g, and so on, over each of the terms. So we have our first term is an x, so we'll have an a over an x. Second term is a 3x plus 2, so we'll have a plus of b over 3x plus 2, and so on. So we have these two terms. Now we're going to multiply out all of this denominator to everything. And this is going to leave us with just our numerator up here when we bring it to here. So we have 31x squared minus 52x minus 14. And then we have our x cancels with our x, 3x plus 2 cancels with our 3x plus 2, and our 5x minus 7 cancels with our 5x minus 7 for each of those terms respectively. So we're going to have our a times, not the x that cancels, so 3x plus 2 times 5x plus 7, so here. Then we're going to do the same with the b term. We're going to cancel out 3x plus 2 instead. So now we're going to have b times x times 5x minus 7 and do the same on the c term. And then we have to multiply all of these sets of parentheses out, which will get us to a, which will just get us this line after you multiply everything out. Once you do this, we're going to multiply our factors out. So our a into our parentheses, our b into our parentheses, our c into our parentheses. So this will leave us with this line. Now, these terms are crossed out because of the next step. And that is going to be taking out and grouping like terms. So we have an x squared, an x, and a just regular numbers. So, and we're going to make a grouping for each of those. So we're going to take our x squared and take all of our x squared terms without an x squared and put them in a set of parentheses. And then what I like to do is every time let's say I wrote this, I cross that here, put this, cross that here, just make sure I have everything written. And then we're going to extrapolate that for all sets of like terms. And my next line was just rewriting it to be the full equation, this line plus this line is equal to this line. And that means that we are most way done with the setting up stage. So the next thing we're going to do is take our like terms from the left side to our right side and set them equal to each other. So we're going to get rid of this x squared, take our 31 and put it down here, take this term and put it down here, and that'll get us this line here, which is an equation. Now we're going to do the same with x's and the non-x's, which will get us this whole block here, which is a system of equations. Now you can probably notice that we have a negative 14 here and a negative 14 here, so we can just get that 1 is equal to a. Now, since we have to solve by back substitution, you can technically whatever method you like for the system of equations. The method I'm using is back substitution. So I rewrote the equations here, and I found terms negative 2 and 3 that we can multiply out. That will get us a cancel on our c terms. So after we subtract everything out, we get to negative 155 is equal to negative 31b, and that is equal to 5 is equal to b. Now we're going to plug our b value and our a value back into one of these top two equations with a c value. So, which is down here, so I wrote out my equation again, plugged in my values, then I multiplied everything out and moved my like terms to one side and isolate my c. Got negative 6 is equal to c, and negative 3 is equal to c. Now that we have those answers, we are going to have to write it out as a decomposed fraction form. So we're going to take this up here, and we're going to rewrite it, but plugging in our a value for our a slot, our b value for our b slot, our c value for our c slot. So this is the final answer of the equation. But to check your answer, what you're going to do is add all of these fractions together and check if it equals what you originally had up here. So we're going to multiply out all of our denominator terms to get a common denominator. So x, 3x plus 2, 5x minus 7. Once we multiply those out, we get that this bottom term is equal to the same as at the top here, because it's the same factors. 15x cubed minus 11x squared minus 14x, our denominator. And then we're going to multiply our 1 times our x cancels. So 1 times 3x plus 2 and 5x minus 7. 5 times x and 5x minus 7. And 3 times x and 3x plus 2, which I wrote out over here. After that, you're just going to extrapolate your terms out by the distributive property, add all like terms together, and once you get a final answer down here, you will see that it equals this up here. And that is how you solve a decomposing fractions equation.